Assalamualaikum and hi to Dr. Ili Najaimi and my fellow friends. So now my group, which is from Group 2, will present about our AutoCAD project, which is we do wind turbine with AutoCAD. So I will pass to the first presenter. Thank you.
So good morning to Dr. Ili, and I'm going to present a part of introduction. As we know, our title of the project is wind turbines. So wind turbines are the modern version of a windmill, and wind turbines convert wind energy to electricity using the aerodynamic force of rotor blades, similar to an airplane wing or helicopter rotor blade. Wind turbines offer several advantages, such as a renewable resource to generate clean electricity without depleting natural resources. The second one, wind turbines are environmentally friendly, it emitting no greenhouse gases or air pollutants. And wind turbines also can act as a mitigation climate change by reducing greenhouse emissions associated with fossil fuel based electricity generation. For the project in our group in computer-aided design, which is known as CAD, wind turbine is chosen as our design. It consists of a tower, blades, and a generator. These three parts working together to convert wind energy to electrical energy. We utilize the AutoCAD software into the design and development of the project, and refer various wind turbine design to enhance our drawing project.
Thank you, Anwen. So next I will present about product background. So about a product which is wind turbine. The development of a wind turbine using AutoCAD is a result of the advancement in engineering and computer-aided design technology. A wind turbine is a device that converts the energy from compressed air or gas into mechanical power, which can be harnessed for various applications. The design process using AutoCAD involves creating a visual model of the wind turbine, including the rotor, stator, blades, and other relevant components. So, in summary, the use of AutoCAD in the design of the wind turbine has revolutionized the engineering process by providing a comprehensive platform for creating precise 2D and 3D models. AutoCAD enables us to design intricate turbine components with accuracy and efficient. So AutoCAD also assists in generating technical drawings and documentation that ensuring compatibility and accuracy during manufacturing.
Timmy, and I'm going to continue the presentation with the objectives and scopes. The first objective is to learn the characteristics and workings of a wind turbine. The second objective is to use AutoCAD to create a precise 3D drawing of the wind turbine, including all necessary dimensions, annotations, and also labels. The third objective is to draw the various components of the wind turbine, such as the tower and rotor blades in AutoCAD, and the final objectives for the project is to generate various views of the wind turbine, including plan views and isometric views, to provide a comprehensive understanding of the design.
Okay, next for methodology. In our project, it consists of 6 parts, which are base, water, grade, mess, inner housing, and housing. Hi, Assalamualaikum. My name is Alvin Sofia binti Fazlin Hakimi. My matric number is AN 210070. So for today, I will explain about the methodology of the base in the wind turbine. Firstly, to draw the base, we must first convert the drawing into 3D model. And then we draw a square shape with length of 101.6 mm and fillet with radius 10 mm on each diagonal of the square shape. The square shape was then extruded up to 10 mm. After that, we switch to the front view and we create a trapezium for the early center with length of 21.59 mm and a top wedge of 25.40 mm. Then we revolve the trapezium by 360 degrees by making the center line as the axis. After that, we produce 4 circles with radius 31.8 mm at the midpoint of each side of the square. Then we use press tool to produce hole in the circle. We also add another circle with the same radius as the last circle in the center of the square. And we then squares 90 millimeter so that the hole does not travel through the object. Finally, we draw a square shape with length of 12.7 millimeter in each of the corner of the shape for the screw hole. We also draw a circle with diameter of 6.35 millimeter from the corner of the small form that landed on the surface shape. We repeat the previous step for each of the corner. Then, to make a hole, we press pull by 10 millimeter. So that's all step to draw the base. I will pass to another person. Thank you.
So next is product design for the blade of a wind turbine. So the blade of a wind turbine is the component that responsible for capturing the energy from the wind and converting it into rotational motion. So it is designed in a specific shape to maximize the efficiency of energy extraction. So I began the drawing for the blade profile by using the appropriate drawing tools in AutoCAD such as line, arc, or splines. And then I use AutoCAD editing tools to refine the shape, adjust the curve, and ensure the smooth of transition along the blade. And lastly, I also use AutoCAD transformation tools to mirror or duplicate the blade profile to create multiple identical or symmetrical sections because we know that a wind turbine have three blades. That's all from me. Thank you.
So this is the part of the rotor. The rotor is the rotating part of the turbine. It consists of three blades and a center part of that connecting with the blades, the hub. Uh, for common, it's most likely three blades for a rotor, but it is not really that all of the rotor will be three blade. But a three blade rotor will be have a maximum efficiency. This is the shape of the rotor, and behind it has another hole to connect with the hub.
For lower mass, we create two circles with a radius of 15.88 millimeter and 19.05 millimeter. Then we use the center of the radius as a reference to draw a square with the length of 15.5 millimeter. We bring the circle of radius 15.88 millimeter to a height of 165.1 millimeter using loft command. We use the loft command to both circles and the lower mass structure is done. We continue with moving the square to the same level as the circle of radius 15.88 millimeter, and we join the square using the union command. Next, we use the command, which is named as press pull, to erase the square into the prepared mass structure with depth of 12.7 millimeter. For upper mass, we create three circles of radius of 4.83 millimeter, 12.7 millimeter, and 15.88 millimeter to the SE plane. We move the circle of radius of 12.7 millimeter up to the height of 152.4 millimeter. Next, using loft command to both 12.7 millimeter and 15.88 millimeter circles, we create the upper mass structure. We continue by move the circle of radius 4.83 millimeter to the same level with the 12.7 millimeter circle. Then we use the press pull command to create a cylinder of height 7.5 millimeter from the 4.83 millimeter circle connected to the lofted structure.
So for the inner housing part of the design project, this is the diagram of the shaft part. We began the procedure by drafting a circle with a 9.6 millimeters diameter to be used as the starting point. And then we switched to the 3D modeling software and extruded the design to a length of 85 millimeter as shown in the diagram. So on the top and the bottom of the shaft, we added a 1 millimeter chamfer to improve the design. And the shape was rotated 360 degrees at the tip of the shaft area. And finally, we kept the remaining cylinder while subtracting the revolving form. For the another design part of the inner housing, which is washer. As shown in the diagram, we started the drawing with a circle and with a diameter of 12.7 millimeter and a circle outside of it with a diameter of 22.86 millimeter. We use the press pull command to pull the circle and with a length of 7.62 millimeter. Fillet the circle's edge is done and the final result will look like the shape of a donut. So next we have moved to the another part of the drawing of the wind turbine. This is the part of the housing. As you can see in the diagram, we started the constructing of the main outer housing first. So we created two nearly identical planes. For the first plane, we utilized line tools to draw the wiring cover, connecting the upper and the lower parts by tangent line in case it is a circle plane, and loft command is used to connect the non-circles plane. When two planes are connected, all the solid structure was mirrored to form the complete structure due to the plane that we had drawn is a half plane. Union command is used to combine all the solid structure into one. Next, a reference line is drawn in the inner part of the housing structure and with a depth of the fundamental shell using the offset tool. Then, two more sets of the reference lines were drawn, one between the top flat and the circle, and the other one is near the bottom flat surface. The inner housing was built applying both reference lines, and the press pull command was used along the shell's wall. We then used the line tools to draw the wire cover, and we built a screw-like structure in the middle of the shell by applying the loft command to all the circles. In order to create a space for the shaft and the washer, the inner solid structure of the housing was removed and utilizing the screw-like solid structure. The structure was then again mirrored to get the another half part and to combine and form the housing design.
For the design process, the first step is to make decision of what product that we want to design, and we decompose the product into four major parts. Continue with preliminary and design, and we assembly all the drawing into 3D model, and finally we complete the report.
So the next step is to complete the assembly and explore drawings for all of the wind turbines component and the parts. The picture below shows the final products once all of the wind turbine components has been assembled. The left part is the 2D frame in the AutoCAD and the right part is the realistic frame in the AutoCAD. This is our final result of the wind turbine. So for the conclusion, creating a wind turbine is an important and promising project in the effort to generate renewable energy. Numerous advantages of wind turbines include the generation of sustainable and pure power, a decrease in greenhouse gas emissions, and an improvement in energy independence. We can help create a future that is greener and more sustainable by taking advantage of the power of the wind. Lastly, I would like to conclude that the big wind turbine in the world will only come from the design of the AutoCAD. Thank you for the watching. That's all for our presentation.